This is how blue happens.
When blue light enters the eye, it is focused onto the retina, where cones are located. Cones have a conical outer segment filled with stacks of membrane discs containing photopigments like opsin. They have a cell body containing the nucleus and other organelles. At the synaptic terminal, they connect to bipolar and horizontal cells. Cones are similar to other cones, but contains S-opsin sensitive to blue light. Short wavelengths are around 440 nanometers. When blue light strikes the S-opsin in the cone, the S-opsin's retinal molecule isomerizes, activating the opsin. Activated S-opsin triggers a G protein cascade, which activates transducing, and transducing activates a phosphodiesterase that breaks down cyclic guanosine monophosphate in the cell. Reduced cyclic guanosine monophosphate in the cell causes gated sodium channels to close the S-cone, hyperpolarizes, reducing glutamate release. High glutamate darkness keeps TRPM1 channels closed. Low glutamate blue light allows TRPM1 channels to open. The bipolar cell receives input at its dendrites through synapses with S cones and some input from L and M cones. These synapses use glutamate as a neurotransmitter. The blue on bipolar cell has psi inverting receptors, typically metabotropic glutamate receptor 6 or enters on its dendrites. Produce glutamate from S cones leads to depolarization of the bipolar cell. The bipolar cell's membrane contains voltage-gated calcium channels. As the cell depolarizes in response to blue light, these channels open, allowing calcium influx. The calcium influx at the axon terminal triggers the release of glutamate onto ganglion cells. The amount of glutamate released is proportional to the level of depolarization, which in turn depends on the balance of blue versus yellow light input. Bipolar cells maintain a braided potential, allowing them to convey precise information about the intensity and spectral composition of the light stimulus. Some bipolar cells emphasize changes in the input signal, acting as a kind of temporal filter. This can help in detecting motion or rapid changes in color. Bipolar cells can adapt to sustained light levels, adjusting their sensitivity to optimize their dynamic range. This involves changes in the properties of ion channels and synaptic machinery. High glutamate darkness keeps TRPM1 channels closed. Low glutamate